Hello, everyone. Welcome to SQL Server on Azure Virtual Machines Reimagined series. In this session, we are doing a sizing deep dive. Hello, my name is David Pless. I am a Senior SQL Program Manager. I cover SQL Server on Azure Virtual Machines and SQL Server Storage.
And hi everyone, my name is Aditya, and I also cover SQL Server on Azure Virtual Machines, and I also take care of the control plane aspects of it.
When we look to migrate our SQL Server workloads to Azure Virtual Machines, we must recognize that the user experience is critical, which means that predictable performance is also critical. So there are some key questions that we should ask ourselves and we should be expected to be asked by our application stakeholders and counterparts. First, how can I efficiently run SQL Server on Azure Virtual Machines? This is an important question. We are so used to over purchasing hardware because we plan for the future. So for many customers, the standard rule has always been a 3 to 5 year cycle for upgrading and changing out hardware. There's also the whole, if I don't use my budget, I will lose my budget mentality. And because of this, we tend to give a lot of resource space, say CPU, memory, and I/O, for our SQL Server environments and applications. We often also have servers that are sized with a lot of memory to scale, and we certainly purchase more processing power than we need because we're always planning for the future. We could have servers with multiple gigs of memory go unused, and we're only using a low 10 to 30% of the processing power, even in peak windows. So this could all be perfectly satisfactory on-prem. Now, on-prem, this is okay in a general scenario because we've already purchased the hardware, but it's different in the cloud. This is the difference between CapEx versus OpEx, purchasing versus renting. Now that we are shifting to an OpEx discussion, we want to be resourceful as we possibly can. We want to be efficient as possible. So there's more for the DBA to focus on in Azure, and it goes with the mantra of always be tuning, ABT. And so you're going to hear us say that quite a bit. So we need performance tuning and optimization now more than ever, and it's extremely important to make the right VM size choices when we are selecting our virtual machines and storage. The next question is, how can I tune SQL and storage to get the best performance? Fortunately, Azure virtual machines are much like the virtual machines that we're used to, especially from an administrative perspective. You still have access to the tools that you're used to that you can access from on-prem via VPN or ExpressRoute. You can also access the tools from a jump box. So you should have no problem leveraging your scripts, Azure Data Studio, SQL Server Management Studio, and any of your third-party tools. The point is, it's still SQL Server, and you have access to the same features of the installed product and the same methods that you would use to tune your queries. Now, while running SQL Server and Azure Virtual Machines, we do recommend that you continue using the same database performance tuning options that are applicable to any SQL Server on-prem environment. However, the performance of a relational database engine in a public cloud depends on many factors, and this includes the size of the virtual machine and the underlying storage. When creating a SQL Server image, consider provisioning your virtual machines in the Azure portal. We implement many of the best practices, including storage configuration. And in this presentation, we're also going to cover the virtual machines best for SQL Server workloads. Finally, the lift and shift topic. I want to lift and shift, and have my app just work. Okay, so Azure Virtual Machine is certainly the easiest path to Azure because it's a virtual machine that we have already been used to. And we're used to that virtual solution for SQL Server. We've been doing it on-prem forever, right? So we have multiple methods that we can use to migrate our databases to the cloud. We also have Azure SQL Managed Instance, very, very easy to approach as your first path to migrating existing databases and applications. So we recommend following the data migration guide to make sure you're following a prescriptive approach to migration. When it comes to your migration methods, it depends on the size of the database, how busy your environment is, and your tolerance for downtime. And many of those topics are included in the database migration guide, which is simply datamigration.microsoft.com. So the key points here are most of the performance monitoring and tuning methodologies from on-prem SQL Server still applies. The performance of a relational database in a public cloud depends on many factors, the size of the virtual machine and the configuration of your data disk. And your paths for migration start with your datamigration.microsoft.com, the data migration guide. I would target a managed instance solution first. If there's any blockers or any scenarios that prevents a migration to managed instance, definitely recommend Azure SQL Virtual Machines as a absolute easiest approach to migrating your SQL Server solutions to the cloud. It is still SQL Server, and we should recognize that we are DBAs no matter where our workloads are stored. In the cloud, on-prem, in a hybrid deployment, it doesn't matter where SQL Server is running. DBAs are needed to make sure SQL Server runs optimally. So there's always best practices we should consider. For example, we should still evaluate and enable log pages in memory in order to prevent the system from paging SQL Server data to the virtual memory stored on disk. We recommend setting an appropriate value for max server memory to limit the amount of memory that SQL Server allocates and to leave enough memory available to Windows and other applications. Of course, the best approach is to monitor memory available megabytes to address this consideration. We should evaluate instant file initialization, and we should recommend the standard SQL Server best practices and tuning methods since we often cannot make query changes. So many of these recommendations can be helpful, including leveraging query data store to get an assessment of your usage and query plan state before you migrate. This way, with any plans that may change after you migrate and any plan regressions you may have, you will be able to force a plan when needed. Query Store can help with parameter sniffing scenarios, general monitoring, and more. So keep a close watch on the SQL Server Best Practices article where we have a lot of these recommendations. All of this will help encourage optimal performance, but these are mostly the same approaches that we'd take on-prem. As you will learn in our Azure SQL Virtual Machine Reimagined session on storage, IOPS and throughput testing is critical and a first step. So start with collecting peak IOPS requirements for your data log in TempDB. Choose a virtual machine that can scale to the total IOPS requirement. We recommend targeting TempDB on the local SSD, your local ephemeral disk. Use read-only caching for premium SSD disk. Use disk striping to achieve your total data IOPS requirements using storage spaces. Use UltraDisk for extreme low latency scenarios, only for the log file. And monitor your SQL database performance. Let's talk about Azure Virtual Machine scalability and sizing strategies. Azure Virtual Machine is an infrastructure as a service virtualization solution hosted in the Azure cloud, similar to virtualization solutions on-prem. With Azure SQL Virtual Machine, DBAs have access to the operating system and can make direct adjustments in software installation and modifications as necessary. Multiple editions of SQL Server, of the Windows operating system, and releases of Linux are available, as well as customized and templated deployments in the Azure Marketplace. You can choose from images with Windows Server, Red Hat Enterprise Linux, SUSE Enterprise Linux Server, or Ubuntu Linux. There are over 375 different virtual machine sizes grouped in 6 different VM series types. Fortunately, there are only 3 main series types we recommend for SQL Server consideration, with only 6 different series sizes recommended for SQL Server use. So in summary, Azure SQL Virtual Machine is perfect for lift and shift scenarios as we have described, and is the most direct approach to migrating your SQL Server-based solutions to the cloud. Azure Virtual Machine gives us the flexibility of virtualization without having to maintain physical hardware that runs the virtual machine. And additionally, Microsoft offers a number of methods to migrate your applications, where datamigration.microsoft.com is the best resource for pre-migration, during migration, and post-migration steps. Azure offers virtual machine types and sizes that can address almost every type of workload, from dev test workloads, burstable, mission-critical production workloads, small-scale to large-scale systems that would support SQL Server and SAP. We offer VM series optimized for compute, memory, disk, GPU-intensive, and more. The portfolio is constantly growing. But for our purposes, we are focused on SQL Server and data warehousing workloads that offer 4, 8, 16, 32, and higher core counts, a strong memory to core ratio, and solid throughput with the right mix of performance features. For this reason, we optimize for 2 main VM types for enterprise workloads and another type for special considerations. First is the memory optimized type. The memory optimized VM type offers large amounts of memory and CPU, high memory to core ratios that's strong for relational database servers, premium disk and cache support, and write acceleration capabilities. In this space, we really like the EDS v4 for the best SQL Server VM series for enterprise workloads. On the next slide, we will double-click on this series type to discuss other virtual machine series in this space. Second is the general purpose and confidential computing type. For departmental workloads, and by this we mean lower user counts, maybe smaller purposed shrink wrap applications that need local database support, we recommend some of the machines in the general purpose and confidential computing type. The general purpose VM type provides balanced but lower mem to core ratios and still might be good enough for smaller departmental database servers. In particular, we recommend the DDS v4 series because of the premium disk support and better temp storage. Storage optimized is an honorable mention for specialized workloads in the storage optimized VM sizes. These machines have high disk throughput and I/O and can be strong for big data, ETL, operational data store, and data warehouse processing. The key feature of the LSV2 series is very high throughput and low latency storage with directly mapped local NVMe, which is ephemeral in nature. The ephemeral nature of the disks are the biggest point to architect around, as well as the fact that this series does not have premium storage caching. For these machines, there's a consistent 8 gigs of memory per core and one 1.9 terabyte NVMe SSD device per 8 CPUs. Again, the local NVMe storage is ephemeral, and storing data files on ephemeral NVMe storage could result in data loss when the VM is deallocated. For this reason, we recommend that this series be used in scenarios where you can recreate from your source data, perhaps in an Azure data lake or stored in another relational data store. The memory optimized virtual machine sizes are a recommended choice for SQL Server VMs. The memory optimized virtual machines offer strong mem to core ratios and medium to large cache options. Through testing and customer feedback, the EDS v4 series is considered the best all-purpose SQL Server virtual machine series. The EDS v4 series is designed for memory-intensive applications. These VMs have a large local storage SSD capacity, strong local disk IOPS, up to 504 gigs of RAM, and improved compute compared to their counterparts. There's nearly consistent vCore to memory ratio of 1:8 across these virtual machines, which is ideal for standard SQL Server workloads. This VM series is ideal for memory-intensive enterprise applications and applications that benefit from low latency, high-speed local storage. The EDSB4 series virtual machines support premium storage and premium storage caching. There are constrained core sizes available for the 64 and 80 core options. We're going to cover the constrained core concept in the following slides. So don't worry if you haven't heard that term before. We'll discuss constrained cores coming up soon. The EDSB4 is ideal for memory-intensive enterprise applications. It has solid core-to-memory ratio. It's really just an all-around strong, all-purpose SQL Server virtual machine. Next, we have the M series. And the M series offers vCore counts in memory for the absolute largest SQL Server workloads. The MV2 series instances are even further memory optimized to support large in-memory databases and workloads that require higher amounts of memory, which is ideal for enterprise relational database servers, very large cache scenarios, and in-memory analytics. Some of the features of the M and MV2 series that are attractive for SQL Server performance include premium storage caching, ultra-disk support, and especially write acceleration, which is unique to the M series. The core-to-memory ratios of 1 to 30 are without constrained cores. You can get up to 1 to 121 core-to-memory ratio support with constrained cores. So this is why this series is considered for mission-critical and data warehouse virtual machine options. Finally, the DSB2 11 to 15 are really good entry-level SQL Server virtual machines for smaller environments. They offer consistent core-to-memory ratios of 1 to 7 across the virtual machines, and they also support premium storage and premium storage caching. There are also constrained core sizes available. All right, let's talk about constrained cores. There is a naming convention around the virtual machines. So when we see a standard E64DSV4, that actually means something. And basically what we have here is a naming convention breakdown of the family plus the subfamily, then the number of cores, any additive features, the acceleration type, and the version. Now, it may seem complicated, but it's actually quite simple. So the standard E64DSV4 means that it is a standard virtual machine. It is the E series. There's 64 cores. The DS, as you can see on the screen, means a local temp disk is present and premium storage capabilities are present. And then it is a version 4 of that particular machine series. So for SQL Server scenarios, what we really want is what's highlighted here on the screen. We really are looking for scenarios where we see that there's a local temp disk present, strong for ephemeral disk for tempDB. M means there's a large amount of memory for a particular size, and there's premium storage capabilities present for when you see S. So I tend to look for those MS machines. I'll target those right away. I means it's isolated. And you may have some security scenarios where you want an isolated VM, so you would particularly pay attention to that. But for SQL Server scenarios in particular, the D, M, and S, those additive features are something that I go for right away. So let's take a look at how this is applied to maybe some other machines. So here we have the E80 IDS v4. And to look at the machine and understand that, we know it's an E-series machine. We know that there's 80 vCPUs available or cores. And IDS means it's isolated. A local temporary disk is present. And S means that we have premium storage capabilities for this particular machine. Here's another scenario, an M128MS. So we know that it's an M series, has 128 cores, and it is memory intensive, has large amounts of memory, and it means that it has premium storage capable features present. Now, we have another scenario to look for, and this is the constrained core situation. So we're going to break this down here in a moment, but What this means here is that I have an M series, 128 cores for the parent machine, but there are 16 cores that are going to be available for this constrained core option. And this 16 cores are what you are going to license for SQL Server. And then, of course, the additive features of a large amounts of memory and then premium storage is available for this virtual machine. So let's talk about this constrained core concept a little further, and you'll learn how constrained cores can give you larger amounts of memory at a smaller licensed scenario. It is important to note that constrained core virtual machine sizes are only available for the memory optimized type. And still, constrained cores are not available for all virtual machines within the memory optimized type. So where would constrained cores be beneficial? Well, in short, constrained cores help save on licensing costs while maintaining the I/O throughput and memory of the parent machine. And because the core count goes down while the memory stays the same as the parent, the memory to core ratio increases with constrained core virtual machines. So some database workloads like SQL Server require high memory, strong storage, and I/O bandwidth, but they don't need the high core count. Many database workloads are just not CPU intensive. So Azure offers these constrained core VM sizes where you're constraining the VM CPU count in order to reduce the cost of software licensing while maintaining the memory, storage, and I/O bandwidth performance. The vCPU count can be constrained to 1/2 or 1/4 of the original virtual machine size. These new virtual machine sizes will have a suffix that specifies the number of active vCPUs to make them easier for you to identify. For example, the current VM size, the standard M32MS, comes with 32 CPU, 875 gigs of RAM, 1 terabyte of temporary storage, 32 disks, and 20,000 IOPS, or 500 megabytes per second of uncached throughput. The new VM size, the standard M32-16 and the standard M32-8MS, comes with 16 and 8 active vCPUs respectively, while maintaining the rest of the specs of the standard M32MS parent machine for memory, storage, and I/O bandwidth. Now, the licensing fees charged for SQL Server are constrained to the new vCPU count, and other products should be charged based on the new vCPU count. This results in a 50 to 75% increase in the ratio of the VM specs to the active billable vCPU. These new VM sizes allows customers to use the same memory, storage, and I/O bandwidth while optimizing software licensing cost. It is important to note that at this time, the compute cost will include the OS licensing, which will remain the same as the parent virtual machine size. All right, so we're going to do a quick demo here, and we're going to look at the sizing insights that you can obtain from the Azure portal, looking at virtual machine size configuration. So what we're going to do is we are going to take a look at sizing a virtual machine directly out of the Azure portal. We're going to do this in two ways. First, we're going to create a new resource and look at sizing by creating a new resource through creating a new virtual machine template. Then we're going to take an existing virtual machine and look at the sizing opportunities that we see in an existing virtual machine. So all we need to do is create a resource, and then we're going to click on virtual machine. Then we should see something that says see all sizes. And if you see here, currently I'm on a standard D8S V3. So what we want to do is click here on See All Sizes, and then we get this list. So in the list, we see first, these are the ones that are most used by Azure users. But then we have all of these other virtual machines listed. The B series, the A series, the E series, which we definitely like the E series quite a bit. The EDS V4, this particular series is really good for SQL Server workloads. Okay. Then we have our isolated sizes, and you can see that these are broken down. Now, there's some sizes that you may not see, like for the M series and so forth. That simply could be because there's a policy or a quota restriction, some reason I may not see that. You may see something different in your environment. Note that I'm also in North Central US. It could be based upon the region, any number of scenarios that something could be applied that limiting what I'm seeing from a policy perspective. But note that I am showing currently 363M VM sizes. So what I'm going to show you here, and what's really interesting to me, is to not group this stuff. So I am not going to do any kind of grouping. And what that does is it allows me to see this view in this sort of arrangement where I can see the VM, and then maybe I can sort by the amount of memory, sort by the amount of CPUs, right? You notice here I'm seeing all the families, memory optimized. I'm not being filtered or limited whatsoever. In fact, I'm actually seeing all CPU, all memory. There's no filter. Now, here's where it gets really interesting. If I click Add Filter, I can choose to filter based upon the family. And we talked about what we would see here and what we might want to target. And I spoke specifically about looking at the memory optimized. You may, for smaller departmental workloads, look at general purpose, and you may, for, let's say, big data, ETL, some reporting scenarios, keeping in mind that the ephemeral disk would be lost if the machine was deallocated. So if you're storing anything there, you would need to be able to recreate it from the source. One of those caveats, but there's some big data use cases for using storage optimized. So I'll select those three. I'll say okay, right? So that's limiting down what I'm seeing, right? So I'm showing 299 of the 363. I could choose this to filter this further. Let's say that I want to make sure that I have a premium disk. So now I'm showing only 190 of the 363. What if I want to make sure that I have that ephemeral OS disk support, right? Or something else, right? I could filter it based upon size. Let's say that I really want to only pay attention to, let's say, some larger machines. So now I'm only showing 73 of the 363. Perhaps I want to look at, let's say, the ones that have the best IOPS, and maybe I only want to look at machines that have at least 8 CPU, or maybe have at least, let's say, 32 gigs of RAM. And so this is just a method of grabbing this list and starting to narrow it down. So if I know the amount of IOPS that I'm looking for, right, because I've done my measurements, this is going to be a really powerful method for me to come in and quickly grab the machines that meet those scenarios. Maybe I know the amount of memory that I'm targeting. Maybe I'm looking for a particular amount of CPU, right? Now, the way to get this is, remember, so to change this from grouping to no grouping, it groups by default, and then just simply play with the filters here. And I'm not even creating a machine to do this. All I had to do is go in and create a new resource, go into my virtual machines, and then say select all sizes, and then you can start breaking this down further. Okay, so now what we're going to do is we're going to look at an existing virtual machine. So I'm going to go back to my recent resources, and I'm going to click this DP SQL OLTP 02, and I'm going to go to size. So one of the things to point out, and I'm doing this for a specific reason, is I'm going to look at the disk arrangement that I already have. And note that I have 10 disks that are already set up on this machine. So now I'm going to click size. You see this list here, too many data disks? What's interesting is all of the machines that are listed here, the number of attached data disks exceeds the supported data disks for these particular sizes. So this is pretty important to take note of, that the number of disks that you have for a machine, you can reach a disk count point that prevents you from sizing lower than the machine that you're at. So when you're architecting your storage, we tell you to start with P30s, but if the capacity for your needs or your IOPS and throughput calculation for your needs gets to the point to where you're having a higher count of drives than what you would potentially want to size down to from a VM level, you may want to go from P30s to P40s for your data disks to keep the caching opportunity, and potentially look at larger disks for your transaction log, knowing that for those disks, I don't need read caching enabled, and that allows me to pick a disk between a P30 all the way up to a P80. And this is a quick breakdown of how to use the Azure portal to find a virtual machine size that would meet the performance needs of your environment.
Thank you, David. That's an awesome demo. So as David mentioned, how important it is to choose a VM, it is super important to choose the right storage too when you're configuring SQL Server on Azure virtual machines. Now, these are the three types of typical choices that our customers generally use when they are configuring SQL servers on Azure virtual machines. First one is premium storage. Premium storage comes in different classes, that is from P30 till P80. What is this premium storage? This premium storage is a remote storage. So the pretty important point for this premium storage is this is the minimum storage that you folks really need to use when it comes to SQL workloads. The second is this storage actually gives you guaranteed IOPS and throughput, guaranteed IOPS and throughput. And also this gives you the single digit millisecond latency, and it is used for most of your operations. So when you choose premium storage, you choose when it is based on the size, right? So if you have 1 terabyte of disk, you would use P30, 2 terabyte is P40, so on and so forth. Generally, what we recommend people for customers is to pool this like take like if you have a workload of like 10 terabytes, we would recommend you to pool 10 P30 disks in a storage pool and use premium storage. Now, there are few customers and there are few workloads where the workload is high IO intensive, right? So they want sub-millisecond latency and they really can't tolerate single-digit millisecond latency. For those kind of customers, for those kind of workloads, we prefer you go choose UltraDisk. UltraDisk is the right choice. Having said that, UltraDisk comes with cost. So it is costlier than premium disk. So instead of you picking UltraDisk, you might need to say, can I really go and do a storage pool? That's a choice. But if you are really saying the sub-millisecond latency, and if your application is having high your application is highly IO intensive, I would prefer you go and choose UltraDisk. Coming to local ephemeral disk. Local ephemeral disk is the local storage that you have for the VM, and this storage is whatever you store in it is kind of not persistent, and it is also extremely performant because it is locally attached to the VM. So we prefer you keep all your TempDB, right? Your TempDB should be configured in this local ephemeral disk. That way, more performance is guaranteed of your TempDB. Now let's come to some basics, right? Let's set the notion. How? Okay, Aditya, you told me that these are the 3 types of disk. Now, how I should really choose this? What is the way I need to choose this? So for you to choose this, the important thing that you need to do is to make sure that you are measuring your workload right. So that's the reason why I'm going to spend some time on this slide. It is so important. It is so important to know what throughput means. Throughput is nothing but how much data an application is processing per request. So this is something that you need to calculate. Now, how you would calculate your throughput? It is dependent on the IO size and the IOPS that you give that your application gives to SQL Server. So now SQL Server decides the IO size by itself. You would really don't have much control over it. And your application decides your IOPS. Now there are multiple ways you can calculate this. I'm going to cover that. But there is one other parameter that you really need to measure is the latency. That is, from the time I submit that request, the time you get the response, what is the time difference between that? That is called the latency. And you need to calculate that latency also. That's also pretty important. Now, Aditya got it. Now, how I would calculate all that? These are the few metrics. These are the metrics that you can calculate from the perf month. All the seasonal DBS would have for sure seen this, metrics n number of times, and I'm repeating the same. So all you would need to do is to run your workload, calculate these counters. If you want to know what is the number of IOPS you want, the perf month counters that you need to do take is disk reads per second, disk writes per second. If you want to understand what is the throughput, it's the counters that you need to really be taking is disk read bytes per second, disk write bytes per second. And lastly, the way you calculate latency is average disk seconds per read and average disk seconds per write. I cannot emphasize enough here because I myself moved so many workloads from on-prem to cloud when I was DBA in my past life. And without really understanding these factors, choosing a storage and choosing a VM is really shooting ourselves in the foot. We should not be really doing that. We should make sure that we are we are calculating these counters and our workload very appropriately, and then choosing the disk based on that. Now, let me guide you how to choose the disk once you collect this once you have quantified your workload. So this is the table that you see in any docs that is mentioned that Azure Disk Storage or Azure Storage has. You have multiple columns which talks about CPUs, memory, what is the uncached disk throughput, cache disk throughput, and everything. Let us debunk each and every column. So max uncached throughput IOPS and Mbps. This is the column that you should be relating to the throughput that you have calculated from your workload. And the max cached, this is the local storage throughput and local storage IOPS. So I mentioned previously, right? Azure gives you the caching capability, and that is the place where you have to store your TempDB. This cached temp storage throughput is the column which really talks about that local storage capabilities. So E16DS v4 has 154,000 IOPS for the local storage, and it will give you 968 Mbps of throughput. And you monitor your CPU, and you calculate saying, okay, this is the amount of number of CPU cores I have, and this is the CPU percentage I have. So relate that to the number of CPUs you have, and same as the memory. So relate the number. So if you have a virtual machine or a physical machine in the on-prem with like 256 gigs or 128 gigs, try to correlate that same with what you have in the memory column. And the other important thing I have seen many customers kind of going wrong is not really concentrating on this column, which is max data disk. So this column is also pretty important. The reason why it is pretty important because let's say you configured P30 disk, right? And it is 1 TB of size. P30 means 1 TB of disk. Now, if you choose that, and if you choose any of these VMs, the maximum number of P30 disks that you can do is 32, which essentially means you can have only 32 terabytes of storage for that machine. That's the reason you need to pay pretty important factor here. The reason is if you want more storage, if you want 64 TB, if you're thinking that your application and your persistent storage can go till 128 TB, you need to choose your disk type based by keeping this max data disk into mind. Lastly, the network bandwidth, this also plays an important role, and you might need to monitor your network bandwidth and try to see how much any VM is giving to you. And we just spoke about the temporary storage that which gives you the number of IOPS and max Mbps. That's the size of that temporary storage that you are seeing. Okay, now that we have learned that how I got a workload, I first understood what I really need to measure. Then I tried to measure with Perfmon, and I took those parameters and I tried to see how the Azure documentation and choose a right storage and right VM for me. Now, once I have done all that, the other important thing while you're configuring your VM is making sure that you are keeping post caching as read-only for all the data disks. Let me tell you again. For data disks, you should be having your post caching as read-only. And there is one other option for you, that is write accelerator, and there is read write cache. But we are not really recommending you to go for read write caching. Please concentrate only on read only caching. Let's talk about write accelerator in a couple of slides. But let me talk more on this host caching. When you keep this host caching read only, as I mentioned, the temp drive which is attached locally will act as your L2 cache, and it will really help your performance. We have done many number of tests with a particular VM spec that David has mentioned previously. We have done many tests, and it is proved that having host caching turned on the database really helps the customers. Let's talk about write accelerator. This is one of the features that is pretty interesting. Write accelerator is a disk capability only for M-series virtual machines on premium storage with Azure managed disks exclusively. The purpose of this functionality is to improve the I/O latency of writes against Azure premium storage. Write accelerator is ideally suited where you have your redo logs or transactional logs. But there are few restrictions that I would say that you really need to keep in mind. That is only smaller I/O sizes, right? Like which is less than or equal to 512 KB are taking the would really take the accelerated path. In workload simulations, where data is getting bulk loaded or where the transaction log buffers of different DBMS are filled to a larger degree before getting persisted to the storage, chances are that I/O return to disk is not taking the accelerated path. So that's the reason why you really need to choose this option pretty carefully. I would suggest you to use this, try this for the log drives only. And one last thing that I really want to call out is, yeah, Aditya, you told that we got it, we really measured, and we really got the workload performance and everything is good. Now, is there anything that you can advise us automatically? Answer is yes. We are working from the Azure VM storage, Azure SQL Server VM team. We are working continuously to make your lives easy, make these decisions for you pretty easy. One of that attempt is when you turn on a marketplace image and you go and try to go to the SQL Server settings and try to configure through marketplace image, we kind of tell you what is the right VM size, what are the number of disks that you might need to choose, all kind of warnings and advices we kind of try to give you when you are configuring storage through marketplace images. One other suggestion, before I give it back to David, one other suggestion that I really have for you is try to create storage pools using storage, which uses storage spaces. So try to create storage pools where you pool good amount of disks, like P30 disks, P40 disks, and make that use storage pool concept more to get as much value out of the storage. Pam, my colleague Pam, she has written a great blog. We are attaching that blog to this slide deck. Please look at that blog where she explains how you will get the maximum throughput using storage pools. Having said that, I'm turning this over to David, who will tell you what else we are doing in making sure that you are choosing the right VM size and choosing the right VM candidate. David, take it over.
Thank you, Aditya. The Data Migration Assistant, DMA, is designed to help DBAs upgrade to an Azure data platform by detecting compatibility issues that can affect database functionality based on your new version of SQL Server. DMA gives recommendations on performance, reliability for your target environment. The new Data Migration Assistant version 5.4 provides support for a new console experience that provides recommendations with an explanation for targeted Azure SQL database, Azure SQL Managed Instance, and SQL Server on virtual machine SKU recommendations based on performance data points. The SQL console application is launched separately and is designed to capture an aggregated set of performance counters as the tool is running, where the service aggregation recommendation phase takes any of the potential candidates and matches them to the aggregated workload. The output is then matched to a set of capabilities, and the result may produce several recommendations. But we take the most cost-efficient option from the potential possible candidates, and this is what is supplied as the target recommendation. The performance capture step is separated from the evaluation step. This is important because this allows a DBA to run the workload manually over a defined workload window and then use the same workload baseline to get a recommendation for Azure SQL Database, Azure SQL Managed Instance, or Azure SQL Virtual Machine recommendations. One of the best features is that you don't have to recapture the workload if you want to examine a different target recommendation. All you have to do is run the evaluation again with a different target type. You will then be supplied with a recommendation and then the reasoning for the evaluation in terms of the machine type and size, as well as resource information for memory, CPU, and storage. Okay, so now what we're going to do is look at a demo of using the DMA console application against a SQL Server-based workload on an existing Azure SQL virtual machine. In this demo, we are going to take a look at the SQL Assessment Console tool that's part of the latest version of the Microsoft Data Migration Assistant. What the SQL Assessment Console tool is going to do for us is it's going to connect, as you can see here, to my local host using integrated security. And I'm going to run a performance collection with the output folder going to the F drive. Now, if that directory does not exist, it will create it for you. This is the simplest approach, the most direct approach to performing a capture. If you want, you can, of course, connect to a local instance or use a different security method. But we're going to use this method here. And I'm going to go ahead and start a workload. Or actually, I'm going to start the SQL assessment capture. Okay, I've started the data collection. Let's zoom in really quick. So you see here that I've started a data collection, and all I have to do to end this workload is just to hit enter. It'll do 20 iterations, capturing aggregate data from this host machine. And this is how you run this SQL Assessment Console app. It's not part of the direct DMA toolset. It is in the program files, Microsoft Data Migration Assistant, SQL Assessment Console path, as you can see here. This is where it'll be started from. Okay. Right. So we have one of 20 iterations currently collected, but I don't have any workloads running. So what we're going to do is I'm going to kick off some workloads, and we're going to kind of bake a cake, if you will. And I'm going to pause the video so it's not running for 5+ minutes. But first, let's kick off some workloads. Now, this is just some random workloads. As you can see, just all kinds of havoc is being is being run in the background. And then I have some just really big table scans that are being run against a couple of upsized AdventureWorks databases. One is against AdventureWorks 2014, one's against AdventureWorks 2016. And then I have a application that was designed for query store testing that basically does a constant flushing of the plan cache and some other executions in the background. And so this mix of workloads should be pretty interesting to create some load against the system. Now, all the while this is going on, I'm going to go back to this window here, and it's going to keep collecting data points. And so what I'm going to do is allow this to continue to run. And when we get all 20 iterations complete, I will stop the collection. Then we'll run the analysis against the same SQL assessment console tool, but the assessment will be doing a workload analysis against Azure SQL Virtual Machine, Azure SQL Managed Instance, and then we'll do another one against Azure SQL Database. So, using the magic of video editing, I will pause here and I'll see you in just a second. Okay, we're nearly done with the 20 iterations I wanted to capture. And what I really want to tell you is it's really important to get defined workloads. So I would recommend getting like the typical business 9-to-5 capture. I would get your data warehouse reload captures, maybe your reporting refresh captures, your ETL processing captures, anything that you can look at and define specifically, this is when this workload runs. I would try to get that capture and then balance that capture, especially, by the way, if you're getting end of week, end of month, any kind of end of period sort of scenarios, I definitely would grab those specific captures and then measure those separately. Because you may find that, you know what, we're from Monday through Friday, we're perfectly fine running at a particular size. But then you may want to resize that VM or Azure SQL database or managed instance, depending on the downtime, depending on the application, depending on the scenario. You may want to resize that to a different target. Okay, so we have our 20 iterations, and now you can see that it's starting anew. So what I'll do is, in this box, hit enter. So what we're going to do is zoom in here. And you can see that, again, I'm running the SQL assessment. But this time I'm doing a SKU recommendation. Using the same output that I used before. And you can see here that I am doing a Azure SQL Virtual Machine assessment. And so what we'll do is run this assessment, and we'll take a look at the output. All right. Size this up a bit. Okay. So here is what we have in this evaluation. We are getting a recommendation for a standard EAS v4. Okay. The family is EAS v4. The machine is an E4, AS v4. And we can see the P30 works just fine. And read-only caching, as we'll learn in the deep dive for storage, read-only caching for the data files, none for the log files, and we're going to be using the ephemeral SSD. You can see that we're using 1.87 gigs of the 32 gig limit for this particular virtual machine. This virtual machine's mem to core ratio is 8, as we've discussed previously about this series. We can see that the IOP, or IO throughput that is, the IO throughput requirement is was within the scope of the virtual machine. And the data storage requirement also fits in for that P30. So this is the evaluation that we were given for this VM. So it gives us the recommendation and the recommendation reason for that capture. And again, I mentioned the defined workloads. So let's take a look at what would happen if I change this to managed instance. And again, I'm using the same capture as before for the VM. So if I look at Azure SQL Managed Instance, you can see here that it's giving me a recommendation for a general purpose 4-core, and it gives us the explanation for that. Again, the 1.8 gigs of memory, the storage for the data files, the I/O latency that fits into the scenario for this particular Azure SQL Managed Instance deployment. Okay. Last, let's take a look at Azure SQL Database. And what's interesting here is if I have, and I did in this case, multiple databases being leveraged for a workload, it's going to give me a recommendation for each database. Okay, so the ticket reservations database at the bottom here, this was what was being used by my query store application. So it's just 2 cores, general purpose, right? There wasn't much going on here. It was that application that was doing the plan flushing just for a query store demo. It's very light. However, I had 2 other workloads that were running random queries against AdventureWorks 2014 and 2016. The 2014 one was some pretty big tables. And in this case, it's saying, hey, you need a general purpose 12-core Azure SQL database because of the workload. You know, there's a lot more going on here. The SQL Server database needs about a gig of memory, a little over a gig of storage for the data files, and they estimated a little over 10 vCores of CPU. Okay, now for the Azure SQL database or AdventureWorks 2016, you can see the recommendation is quite a bit lower than the 2014 one. So it's only saying a little over 3 vCores, a little over 1 gig of memory, right? So in comparison, it's not nearly as large. But what's really nice here is, as I mentioned in the review, is you are getting an evaluation for Azure SQL database for each database, Azure SQL Virtual Machine, and Azure SQL VM with a single capture of a performance workload that you fully control. So this is a great method that you can take for sizing, and it's only available in the latest versions of the tools, and one of those tools is the Data Migration Assistant 5.4, and I believe it's also available for Azure Migrate. And I definitely recommend that you leverage this tool set. And now we'll go back to our presentation. Okay, so we're going to wrap up with some Azure SQL VM best practices. We'll do a best practice summary, discuss some considerations, review some key documentation along with some wrap-up topics in the Q&A. So we definitely recommend choosing the right virtual machine. And as we mentioned, we really want you to target the memory optimized type. And in particular, we really like the EDS v4 because of the IOPS and throughput capabilities. It has a really strong and stable mem to core ratio across the series, and it is perfect for most SQL Server workloads. For your larger memory needs, we do recommend the M series. We find that a lot of customers get a lot of benefit using the constrained core scenario to save on SQL licensing and to be able to use that to drive a better mem to core ratio for that type of virtual machine in the memory optimized set. We definitely recommend choosing the right disk, and to get a deeper view of this, we recommend reviewing the Azure SQL VM Reimagined series on storage. But to simplify it here, we recommend targeting the P30 and P40 disks. And the reason for that is you get the read cache capability for your data files. And we recommend further reviewing the storage session and our documentation for more information on that. We definitely recommend isolating your files, your data, your temp DB, and your log. We treat these scenarios differently with caching. We treat these differently as far as your Azure data files versus your temporary storage, and it also helps for monitoring. As I mentioned, you do want to enable host caching for your data files. You don't want to use host caching for your log files. You don't get benefit. We do talk about this in the storage deep dive. I recommend reviewing that further there. Optimize your configuration based on your workload behavior. This is something that you're going to want to monitor and certainly apply your SQL Server best practices as well. And the type of topics that fit into this is, let's say, data compression, column store indexing, in-memory OLTP. And we also cover this in our best practice checklist. And you're going to get more capabilities for the agent extension storage configuration wizard. Currently to date, I'd say 80 to 90% of the best practices are addressed there, but we're making investments and improvements. So keep your eye on that scenario. Definitely leverage the ephemeral disk or TempDB. We find that it works for most customers, and most customers get a tremendous benefit for having TempDB on that local SSD ephemeral disk. Enable write acceleration for M series that is unique to the M series. It's perfect for low latency scenarios. And leverage Azure Monitor and Metrics to get a proper assessment of your uncached and cached health for your virtual machine, and be able to create alerts and get a deep dive into log analytics for historical health. Here is the key references I strongly recommend reviewing. We're constantly making updates to our documentation. It's really a regular thing at this point. So performance best practices for Azure SQL Virtual Machine, we list quite a bit there, from high availability to from storage and sizing and SQL Server best practices. We break out the VM sizing and storage best practices separately here, and I definitely recommend reviewing Pam's blog, The Biggest Bang for Your Buck with SQL Server on Azure Virtual Machines, and take a look at that. And at this point, please let us know if you have any questions. We've absolutely enjoyed having you. And support Data Platform Summit to support data platform geeks and SQL Server geeks and the community at large. Thank you again. There's 3 ways to win prizes. Please post your selfie with the hashtag DPS 2021. Please give your session and conference feedback, and visit our sponsors and exhibitors, and follow on Twitter at the Data Geeks and at Data AI Summit. Again, thanks everybody, and please ask your questions and give your feedback.